subarray. Yeah, so from the title it's easy to understand. So let's try to understand the problem first. So we are given a circular integer array nums of length n. Return the maximum possible sum of non-empty subarray of nums. Yeah, we need to return a subarray of nums. It cannot be none. It must have some element inside the subarray. Yeah. So what is a circular array? It means the end of the array connects to the beginning of the array. So formally, so we can check it according to this formula. Yeah, of nums I is nums I plus 1 modular n, and the previous element is I plus 1 plus n. Yeah, so according to this kind of formula, we know something about it. So for example, this is element minus 2. So the next element is I plus 1 modular n. So for index 2, so it is yeah, so the next element is index 2. For this is 3, 2 plus 1 modular n is 4, so 3 modular 4, it is 3, so it is the next element. So let's check the next one. So this minus 2, so the index is 3, 3 plus 1, it is 4, so 4 modular 4, so it is the next element of 3. Yeah, right. So what about this element minus 2? So its next element is this index. So the index currently it is 3. So 3 plus 1, it is 4. 4 modular 4, so it is 0. So it means the next element of minus 2, it is 1. Yeah. So this is just yeah, common sense of the next element. So similarly for the previous element, let's check this one. So the index is 0, so this is 1. So what is the previous element? So it is I minus 1 plus n. So 0 minus 1 plus n, n is 4, 4 minus 1, it is 3. So it is this element, index 3 minus 2. So yeah, if you understand this, this is enough for us to solve this problem. Yeah, but here is something else. So the subarray may only include its element of the fixed buffer nums at most once. Yeah, so this means an element, for example, this minus 2, it cannot include 2 times. So for example, it goes from here and go around many times. Yeah, it cannot be like that. You can only include this minus 2 for 1 time, and also for the other element. Yeah, here it is said something very difficult to understand. I don't want to read it, and I don't want to understand it. Basically, this means nothing to me. Yeah, so if you understand this one, yeah, please make a comment about it. Yeah, so for me it doesn't matter, because this I plus 1 to nums z, this is a subarray. There does not exist this I, yeah, less than or equal to k1, k2, k1 modular n equal to k2 modular n. It does not exist. So this just means that there's no duplicate. Yeah, so for example, this is k1 for index 2, there's another k2 for index 2. Yeah, it is just turn around for many times. It does not exist something like that. Yeah, it just means that there's no duplicate element for the subarray. Yeah, now let's try to solve the problem. So we want to calculate the maximum sum. So for this one, so for example, we have the maximum sum of this is 3. This is 3 is the maximum. Yeah, because you cannot find any element. The sum of them will be bigger than 3. Yeah, so this is straightforward. But we should know about that this nums can be turned around. It is a circular array. Yeah, if it is a circular array, we have to think about what about this minus 2 plus 1. So for example, this minus 2 can be, yeah, let's say, yeah, this 1 can be 4, or this minus 2 can be some positive numbers. This 1 minus this one can be the biggest number. So for example, yeah, let me just copy it and from here to explain, yeah, some other cases. Yeah, so for example, this minus 2 can be 4. Yeah, if we check it directly, we got the maximum, like this is 7, 3 plus 4, it is 7. So for example, this number can be 5. Yeah, but currently, what's the possible result? It is 3 plus 4 plus 5. It is 12. Yeah, but yeah, if we calculate directly, we have to turn around, yeah, but that's gonna be difficult. So what if we can calculate the minimum subarray? So what is the minimum subarray? It is -2. And what is the total of nums? Yeah, the total of nums is 12 plus -2, it is 10. So what about the total of nums minus the minimum of nums? So the result should be 12. 10 plus -2, it is 12. Yeah, if we can think about the problem like that, so it's gonna be difficult, it's gonna be easier. Yeah, so first of all, we're gonna calculate straightforward. Just calculate, yeah, from the first index to the last index. So what is the maximum number? It can be something like 3 plus 4, or we can calculate the minimum value. So what about the minimum value is -2? So what is the result? So the result would be the maximum of the two. Yeah, so for one thing, it is the maximum of this array. So for another thing, it is the minimum of the array. Yeah. Now let me, there is another case. So for example, yeah. So what if all the numbers is negative? So the minimum of the numbers. So what is what about the minimum sum? The minimum sum would be -8. Yeah. So currently, what about the maximum? What about the maximum sum? It is -2. Yeah. So what is the what is the sum of the array? So the sum of the array would also be -8. Yeah. But if all the element is negative values, we cannot use the formula like that. We have to check. So if the sum of the values equal to the minimum prefix sum, so this means we have to get the maximum value of the array. So it is -2. Yeah. Otherwise, you're gonna get a wrong result. Yeah, because you know some of them is -8. Yeah, and then you're gonna use this -8 minus the minimum of the array. So what is the minimum? The minimum is also -8, so it's gonna be 0. But the final result cannot be 0. Yeah, it must be -2 because there's no 0. Yeah. Yeah. Now let's try to code it up. So I'm gonna prepare the max of num and minimum of num. I'm gonna prepare two arrays. Yeah. So inside of the array, it's gonna be nums 0 because I'm gonna start from index 1. Yeah. And times n, and here gonna be nums 0 times n. Yeah. And this n gonna be the length of the nums. Yeah. Let me make it. So this n is the length of the nums. Currently, we just prepare two arrays: maximum num and minimum of nums. Yeah. And after that, I'm gonna prepare this one. So for I in range 1 to n, we're gonna check the maximum of nums. So the maximum of I should equal to the max of should be equal to the max of nums I, or it can be nums I plus nums I minus 1. Yeah. Let me check the result later to explain what's the meaning for this one. And similarly, I'm gonna copy the line to check the minimum of nums. Yeah. And it's gonna be the same calculation. So let me just copy. Yeah, here I don't need it. Yeah, here just we need to take the minimum values. So it should be the minimum of num I with nums I plus nums I minus 1. Yeah, let me just return a random value, maybe 9. It doesn't matter. Yeah, but I want to print out the min num and maximum of nums. Let's check the result first. Yeah, so let's check the first example. So for this one, so first of all, let's check the minimum of nums. So first element, it is 1. If we have two elements, it's gonna be and minus 1, because this minus 2 plus 1, it's gonna be the minus 1 for the minimum. And if we have 3 values, yeah, it cannot be 3, because 3 plus minus 2, it is 1. 1 is the minimum. So what about this minus 2? Yeah. Yeah, I think here it cannot be. Yeah, it is nums I. Yeah, that is why. Yeah, here should be nums I, because it cannot be 1. It must be minus 2. Yeah, let me just run it. Yeah, now you can see it is minus 2. It should be minus 2. Yeah, here is just a typo. Now let's check the maximum. First element is 1, and if we have minus 2, it is still the maximum gonna be minus 1, because minus 2 plus 1, it is bigger. And for this element, it's gonna be 3, and for the next one, it's gonna be 1, because minus 2 plus 3 is gonna be 1. So this is gonna be the maximum. Now we can calculate the result. Yeah, normally we can return the result by the maximum of the max num, and with the total value. The total value is the sum of nums minus the minus the minimum of min num. Yeah. So normally this gonna be the result. Yeah. First of all, we're gonna check the maximum of this max nums, and then we're gonna use the total num minus this minimum nums. Yeah. But we have to check if all the element is negative. Yeah. This is why we have to check if this sum of nums equal to the minimum of nums. Yeah, if this one minus this one equal to 0, yeah, so this means if the value is equal, we have to return this maximum of max num. Yeah, I've already explained it. Yeah, because if all the element is negative, you cannot use this formula anymore. You have to check if all the element is negative. You have to check the maximum of the nums. It is minus 2. Yeah. Now let me run it. As you can see, it works. Yeah. Now let me just delete the print and yeah, submit it and check out the result. And the time complexity is easier to. Oh, there's something wrong. Let me check. So for this one, the final result is 14, but I got a 15. This is the sum of them. 8. Yeah, it should be 15. I don't know what is wrong. Yeah, let me just put it inside to check it. Yeah, let me print out the max of nums and minimum of nums. Yeah, I think I get something wrong about this area. So yeah, I cannot use this formula because this dp calculation is not right. So for example, from here, this is 3, here should be 4, and for the next one, I need to use the previous element, but I didn't. Yeah, so I have to use the previous element to check if they're if they're gonna be a bigger value. So it should be nums I plus this maximum of num. Yeah, and similarly here should be plus the minimum of nums. Yeah, I need to accumulate with the previous result to get the maximum sum. So this is basically the dp, the prefix sum. Yeah, I cannot just use 2 elements because that is not the dp solution. I have to accumulate the previous result if it can have a bigger result. Yeah, now let me run it to check. Yeah, as you can see, it works. Now let me just delete the print and submit it. Yeah, as you can see, it works and it's pretty fast, and the time complexity is just O(n) because we never used nested loops. We only used one loop. Thank you for watching. See you next time.